Okay, how are we doing, everyone? Looking at solubility of a few compounds today. So in the bottom of these test tubes we've just got water at the moment. I'm going to see what sort of solubility we can look at here. So first up is an alkane. This is cyclohexane. Hopefully be able to see this one come down. I'll bring that up close to the camera as well afterwards. So we're getting quite a distinct separate layer. Might be a bit easier there. So the alkane's definitely sitting on top of the water there as distinct layers. An alkene, we're using cyclohexene for this one. Now, as we go, we're getting rather the same reaction. So it's sitting on top of the water as a distinct layer. For the ethanol, we're using as the alcohol here. Now that's gone through a bit of bubbling from the test tube, but that's definitely miscible, so that's gone into a single layer. And for the carboxylic acid, we've got acetic acid or ethanoic acid. Quite strong smell. And that's the same again, there's a few mixing lines in there, but that's gone into a single layer, so that's mixed together. So out of those, you have the alkene, the alkane, not soluble, and then the alcohol and carboxylic acid were soluble in water. Okay, so we're going to have another demonstration here. We're actually going to be using bromine water, so it's a solution of bromine bubbled through water, as simple as it sounds. We're going to use that as a test of saturation on the alkanes and alkenes here. So again, we're using cycloalkane and cycloalkene. And we'll see if we can come up here. So take a solution of bromine. So that's each of those. And you'll see quite a distinct orange colour that'll separate on here. So the alkane here, give that a swirl. I'm getting a bit of orange colour into the water. That's just the bromine dissolving in the water there. But we're still getting quite a distinct separate layer. The alkene, let's have a look. Now at the moment it's sitting like that. Still a very distinct separate layer on the alkane. Okay, so given these a few minutes to react, the alkane there, still two very distinct layers, and the alkene has reacted with all the bromine and formed two distinct layers but very clear. So you'll have one of the alkene, one of the water, neither with bromine, the indicative orange colour of bromine in it. Okay, so I'm going to try a few combustion reactions as well. So I've got the alkane here. Now, as you can see, a lot of dark smoke coming off the alkane. Through. Okay, and here we have the alkene. So not unlike the alkane. Still a lot of that dark smoke coming off it. Okay, and the alcohol. So again, we're using ethanol. So a lot cleaner with a distinct lack of black smoke. Now, one thing I did notice coming up here, the watch glasses have actually got different amounts of soot sort of left on them. That's in the alkene. The middle one here, the alkane, so that's quite a lot more sort of debris left over, and the alcohol is nearly clear. Okay, so I'm going to do a quick pH test on these ones for acidity. Now, the ethanol actually doesn't react very well with these pH papers, but that is a neutral reading. So the ethanol come out just above 7 on there, whereas acetic acid will react as mildly acidic. So it's not particularly strong, but it is definitely registering as acidic. So we'll give that a few seconds to develop. Now for a comparison, so you can see that the acetic acid on the bottom is a lot more acidic than the ethanol. Okay, so we're going to test a reaction here between acetic acid and sodium hydrogen carbonate, or baking soda, more commonly known. So we should be able to see, hopefully, see a bit of effervescence here. Add a bit of water, we can actually get it to react. Yeah, we can see the bubbling. You better hear that as well. As we add more water, we can actually get it to react. Bubbling. There's definitely gas being produced. Now, the reaction between the baking soda and the acetic acid is actually the base of the classic baking soda volcano experiment, demonstrated as such. It grows up. So it does produce a lot of gas very rapidly. Sadly, it goes away very quickly.